Hello everyone, this is Sahana LK from second sem from the section Infinity. Today we are discussing about the mathematics subject. In that I chosen a topic that vector line integrations. Vector line integration. It is a mathematical concept used to evaluate integral of a vector field along a curve. It allows us to calculate the work done by the force field along the given path. Vector line integration is an essential tool in physics and engineering for solving problems involving in line integrals. Here what? Evaluate integral f dot dr. If f is a conservative, use the fundamental theorem of line integral. This is the equation to find the vector line integral. F equals to x y square comma x square y. Here integral c f dot dr equals to integral c Laplace f dot dx, which equals to f of x of b comma y of b minus f of x of a minus y of 0. Now, a line integral represents the sum of scalar products of a vector field and the tangent vector to the curve. It measures the contribution of the vector field along each point of the curve. Line integrals can be evaluated in two ways, using parametric equation or in a differential form. If we start with two typical example where integrated is, first one is scalar field, in which line integral of L phi dl where phi of x comma y equals to x minus y whole square. Next, parametric equations represent the curve as a vector function of a single variable. To evaluate a line integral using parametric equation, we substitute the parametric equation into the vector field and compute the integral. Next, the result is a scalar value representing the total contribution of the vector field along the curve. Here, it is a x-axis. This is a y-axis, this is the z-axis, in which gamma naught and the gamma are passing from the origin. Gamma equals to gamma naught plus gamma t. Here, x equals to x naught plus at, y equals to y naught plus bt. This what the parametric equation represent x minus x naught divided by a equals to y minus y naught divided by b equals to z minus z naught divided by c. Next, differential form of line integral. A differential form represents the curve as a differential equation involving partial derivatives. To evaluate a line integral using a differential form, we express the vector field as a differential form and integrate it over the curve. This method allows for more flexibility in dealing with the complex curves and the vector fields. This is what d by dx of integral a to x f of t into dt equals to f of x. First, we should derive it of an integral. This is what derivation of the integral. Derivate matches upper limit of the integration. Here upper limit is the x, lower limit is the a. Lower limit of integration is a constant. Here a is a constant. As next shall we go through the properties of vector line integration. Vector line integration is a path dependent, meaning the result can vary depending on the chosen curve. It depends what in which we curve we have chosen. And next, if two curves have the same endpoints, the line integral along them may differ. The line integral is dependent of the parameterization chosen for a given curve. Next, calculation techniques for line integrals. Techniques such as the fundamental theorem of line integrals and Green's theorems can be used to simplify line integral calculation. The fundamental theorem of line integrals relates a line integral to an antiderivative of vector field, Green's theorem, which allows us to compute a line integral by evaluating a double integral over an enclosed region. This is what basic properties of integrals. Through this section, we assume that all functions are continuous on the closed interval I equals to closed interval a comma b. Below, r is a real number, f and g are the functions. Here, first one is integral 0 to c f of x into dx equals to c. In second condition, integral a to b f of x into dx equals to minus f of a b comma a f of x into dx. It is what the antiderivative. Next, third, integral a to b f of x into dx which equals to integral a to c f of x plus dx plus integral c to b f of x into dx. These are the properties of integrals from the definition of integrals as limits of Riemann sums. Next, applications of vector line integration. Vector line integration is used in physics to calculate work done by the force field along a path. It is also used in electromagnetism to calculate the circulation of a magnetic field around a closed loop. In fluid dynamics, vector line integration helps to determine the flow of fluid along the curve. This is what ordinary integration of vectors. The ordinary definite are the indefinite. Integral of vector is done by integrating each orthogonal component separately. If there is a vector v equals to v of t, where t is a scalar variable, then we define it is a vector integration. The equation represents integral v of t into dt equals to integral vx of ti plus vy tj plus vz into tk dt. This is what the constants are taken out from the integration. I integral vx dt plus j integral vy dt plus k integral vz dt. Here I, j, k are the unit vectors. Limits and the challenges. Vector line integration can be challenging for challenging complex curves or vector fields. Vector fields that lack symmetry. Calculating line integrals analytically may not always be possible, requiring numerical methods or approximations. Some vector fields may have non-zero line integrals along closed curves, indicating the presence of circulation at the potential barriers. This is what the calculation occurs here. If integral c f dot dr equals to integral 0 to 1 t cube comma t5 comma t to the power of 4 dot 1 comma 2t comma 3t square into dt. If we done for this integration, total answer we are getting 27 by 28. Here integration of t cube is the t4 t to the power of 4 divided by 4. Vector line integration in practice. Software tools like MATLAB and the Mathematica provide built-in functions for computing line integrals. These tools simplify the process by automatically handling the numerical calculations and allowing for visualization. Vector line integration is widely used in various fields such as physics, engineering, and the computer graphics. At last conclusion, vector line integration is a powerful mathematical tool for evaluating the contribution of a vector field along a curve. It allows us to calculate work done, circulation, and flow rates in various physical and engineering applications. Undertaking the principles, techniques, and applications of vector line integration is essential for solving real-world problems. At last conclusion, we are concluding that the vector line integration is used in the application to find the curve of the equation or the curve. Thank you for the listening.